Computers are nothing more but sophisticated calculators. They are very fast at doing arithmetic. This is great for doing tasks that match what a calculator does, summing numbers to work out sales, applying percentages to work out tax, plotting graphs of existing data. It may surprise you, but reconstructing a video frame from the ones and zeros that are piped across the internet to your computer is done using arithmetic not much complex than what we did at school. Adding up numbers really quickly, thousands, or even millions in a second. It may be impressive, but it isn't artificial intelligence. A human may find it hard to do large sums very quickly, but the process of doing it doesn't require much intelligence at all. It simply requires an ability to follow very basic instructions, and this is what the electronics inside a computer does. Now let's flip things and turn the tables on computers. Look at the following images and see if you can recognize what they contain. You and I can look at a picture with human faces, a cat, or a tree, and recognize it. In fact, we can do it rather quickly, and to a very high degree of accuracy. We don't often get it wrong. We can process the quite large amount of information that the images contain, and very successfully process it to recognize what's in the image. This kind of task isn't easy for computers, in fact it's incredibly difficult. These kind of tasks motivated scientists to replicate human brain into a world of computers so that such tasks can be performed easily by computers also. That's when neural networks came into the picture. Neural networks are computational replication of our nervous system. Like our nervous system, neural networks are composed of large numbers of interconnected artificial neurons known as perceptrons. These artificial neurons are based on the mathematical function that takes place in biological neuron. Artificial neural networks consists of multiple layers. Input layer, it can be considered as our sense organs, which captures the data from surroundings, like eye for object recognition or ear for speech recognition. Hidden layer. In it undergoes processing of data that was captured by our input layer, which can be considered as the processing that goes on in our brain. Output layer. It can be considered as our understanding of the captured data. This understanding can be considered as labels in the cases of classification. And computer learns these labels by extracting features from vast amount of data again and again. These detected features then ascertain their matching labels. Feature extraction takes place in hidden layer of neural networks. Before all this, let's talk about perceptrons. Perceptrons are based on our biological neurons. Our neurons takes an electrical signal as input and gives another electrical signal as output. Neuron only gives an output when input signal is more or equal to a certain value called threshold. And when threshold value is reached, then only neuron produces an output to be entered in another sets of neurons. We call it firing of neurons. Similarly, in perceptrons, the predefined function decides if perceptrons fires or not based on the threshold given. Functions that are used in perceptrons are called transfer functions. Some of those commonly used functions are step function, sigmoid function, rectified linear units. Neural networks have become a very important part of machine learning, as they can derive or learn meaning from very complicated and even imprecise data. They can extract patterns or trends which are very complex for other machine learning techniques. Neural networks can cover wide scope of problems. In neural networks we have nodes connected with each nodes of next layers. Each of these nodes are perceptrons. Now, in the input layer perceptrons, we insert instances of our input data, and then these input layer nodes triggers the nodes of next layer and the information flows on. Information flow takes place only when the input value reaches the preset threshold, similar to the process of firing of neurons. Each node from one layer shares a connection with each node of other layer. These connections in some cases have to be strong and in some cases have to be weak, so as to make it similar to the behavior of our neurons. Hence, we need a parameter which can emphasize or de-emphasize strength of these connections. We call such parameters as weights. The function inside perceptrons is a transfer function. We add a parameter called bias to these transfer function. Such neural networks where information flows only in one direction are called feed-forward networks and have predefined sets of weights and biases. Here is an example of implementation of XOR function by feed-forward gates. We implemented combination of AND function and OR function in a input layer and, then their respective predefined weights and biases triggered into hidden node. As a result we get our output, XOR function. But feed-forward nets are not enough for implementation of complex functions. We can't know the value of appropriate weights and biases beforehand. So we need to come up with a process in which weights are learned by the network itself. That's where process of backpropagation comes in. Backpropagations is a process with main objective of error minimization. Error minimization starts by finding out the difference between the obtained outputs and known or desired outputs. Then to obtain the minimization of the error, weights and biases are tweaked layer by layer and perceptron by moving in backward direction. Tweaking of weights is achieved by gradient descent. Gradient descent is an optimization technique which is used to find a local minimum by taking small steps at time. These small steps corresponds to tweaking of weights and biases. It is also known as hill climbing approach, as in hill climbing we reach at hill's peak by taking single step at a time. Neural networks have multiple areas of applications in our world, varying from simple applications like image recognition, object recognition, speech recognition to more widely useful applications like chatbots, virtual assistants and Apple Siri or Microsoft's Cortana. Most mesmerizing products of neural networks are robots that can cook and self-driving cars. We'll present you with mathematical example of simple neural networks in next video. Till then, goodbye, adios, au revoir.